Assalamualaikum everyone, we are from Group 5. We're going to present about pulse modulation and multiplexing. So, pulse modulation is utilized in various communication systems. It is a critical concept in the field of signal processing and communication system. So, what is type of pulse modulation? First, pulse amplitude modulation (PAM). Second, pulse width modulation (PWM). Third, pulse position modulation (PPM). Fourth, pulse code modulation. What is the difference between these types? PWM is less susceptible to noise. PPM is less susceptible to noise compared to PAM. PAM is easily affected by noise. Next is sampling. The sampling converts the analog signal into discrete form by obtaining samples of the information signal. But this process must follow sampling theorem, which is Curies theorem. This sampling theorem follows a continuous signal that is sampled at a rate greater than or equal to twice its highest frequency can be adequately represented. From the picture, we can see the difference between adequately sampled signal with the earliest signal due to undersampling. Based on the Curies theorem that has shown the formula, it is to overcome duplication and loss of information. Quantization is the process into dividing a signal's range of possible values into an infinite number of neighbors, which are subsequently represented by a digital code. The process of converting continuous signal into digital signal. There are two types of quantization. So first is uniform, second is non-uniform. Uniform quantization has an equal spacing between the quantization level. As the figure show mid-rise type uniform quantization. For the second figure, it is mid-trip type uniform quantization. Second type of quantization, it is non-uniform quantization. It has an equal spacing between the quantization level shown in figure.
Alright, now I will explain about the bit depth. So what is the bit depth? Bit depth is the number of bits used to record each sound sample. The higher the bit depth, the more details can be captured. For example, 24-bit audio can capture more subtle sounds than 16-bit. When sound is recorded, it's broken into tiny pieces and the bit depth determine how much detail it can save in one piece. Using the higher bit depth means the recording will be more accurate and true to the original sound. Okay, what is the bit depth consideration? When recording sound digitally, the system asks how loud is the sound. The answer is represented by the bit depth, which includes first, how many loudness levels can be recorded. Second, how loud the sound can be before the distortion occurs. Alright, for example, CD quality audio use 16-bit depth. This gives 65,536 levels of loudness, which is 2 power of 16. These levels are split into positive and negative, which is loud and quiet values, and 32,667 for loud sounds and 32,668 for quieter ones. Think of it like capturing sound on a scale from 1 to 16,536, where every little change in loudness gets its own step. So how much sound can it handle? Each bit adds about 6 decibels dB of loudness. For 16 bits, this means the system can handle 69 dB of sound without distortion. Example, at a concert, the loudest sound might be a loud cheer, around 100 to 130, but 16-bit audio can only capture sounds up to 96 dB without losing clarity. So how much sound can handle? Human can hear sound up to 100 and 130 dB. So 16-bit audio may not capture the full range of the sound we can hear. To cover more detail, maybe we can use 24-bit audio, often used by the professional recordings, allowing for greater dynamic range.
What is multiplexing? Multiplexing is a technique used in communication system to combine multiple signal or data stream into a single transmission medium. There are two main objectives of multiplexing. The first one is to efficiently utilize the available bandwidth of a communication channel, and the second one to enabling the simultaneous transmission of multiple data stream over the same physical medium. The purpose of multiplexing is very simple, which is to maximize the efficiency of a communication system and to reduce the cost of transmission by minimizing the need to separate physical channel for each signal. You can see multiplexing is used in many areas, including telecommunication, for example for voice and transmission, broadcasting, for radio and TV channel, and also for internet. There are 4 main types of multiplexing. The first one is time division multiplexing. The second, code division multiplexing, frequency division multiplexing, and also wavelength division multiplexing. Time division multiplexing, signal are assigned specific time slot in which they can use the entire channel bandwidth, which means that the signal takes turns using the channel at specific time. Frequency division multiplexing, each signal is assigned a specific frequency within the bandwidth channel, which means that frequency is assigned a unit frequency range within the channels. Code division multiplexing, signals are encoded with unique code and transmitted over the same channel simultaneously. For wavelength division multiplexing, in optical fiber, signals are transmitted using different wavelengths of lights.
So now it is 5G advancement. So what is the 5G? 5G is the fifth generation of mobile networks, the latest and the fastest way our phone and device can connect to the internet. It's like upgrading from the 4G to the 5G. Think of the 5G the super fast sports car. So do we need it? Into this note, we use more devices than ever: smartphone, smartwatch, smart homes, even smart cars. This device need internet, quick response, and the ability to all work together without slowing down. Imagine a highway. So FDM, frequency division multiplexing, there's multiple lane for cars to travel without traffic. And QAM, quadrature amplitude modulation, makes each car carry more stuff and more data. So what can we get with the 5G? So it is really fast. With 5G, downloading a movie just takes seconds instead of before it takes about hours. Performing streaming, gaming, and using apps that needs a lot of data. Next, no delays. 5G reduces the times it takes for device to communicate. For example, if you're playing an online game or controlling a robot, there's no lag. Next, connect more device. 5G can handle thousands of devices at once. So your phone, smartwatch, fridge, even your car can stay all connected without slowing down. Do we need to care about all of that? Sure, we must. 5G isn't about the fastest ones, it is about new possibilities. Healthcare, remote surgeries using robots, cities, smarter traffic system to reduce jam. Entertainment, immersive virtual reality, VR experience. It's not just a better internet, it is shaping our future.
Many people assume that higher frequency 5G can cause harmful to the body such as cancer, infertility or neurological disorder. This is wrong because type of radiation used in 5Gs are RF wave, microwave, visible light and also non-ionizing energy. Even if it's high frequency, it's still safe to use. So if it's higher in frequency, that means it has a low penetration rate. So that means you don't need to worry about it able to reach deeper to the tissue. The only thing that it only has thermal effects, yet still regulated by the international guideline. Due to the lack of understanding, many said that digital communication is secure, but it's actually quite the opposite. Such vulnerabilities in technology is when you have a communication with others and hackers are able and has the opportunity to intercept your communication, causing misleading. And then files containing malware can also easily be shared. Mismanagement by service providers where employees with access able to leak their customers' data. Some governments require backdoors, allowing unauthorized access. And lastly, even the secure platforms are not immune to data breach. So that's the misconception in digital communication. In conclusion, we have learned that pulse modulation able to convert from analog to digital signal. Bit depth determine the signal resolution and quality. Multiplexing allow multiple signal to share the same communication channel. 5G advancement bring transformative capabilities for pulse modulation, and misconception about 5G where it highlights the need for education and transparent communication. So what we learn here is that we have learned the potential of digital communication, emphasizing the need to continue the innovation, ethical practices, and public awareness to fully realize the benefits. So that's all from us. Thank you.